Hey everyone. So you start a project, you make your character, you get all your materials done, you get it rigged, you pick a pose, you do the lighting, and finally you render it out. And then what? There's a big difference between a finished render and a finished piece of artwork. Even when you're working with very established and complete workflows like photorealism for architectural visualization or product rendering, it takes quite a bit of post work before any individual piece is really complete. When doing stylized rendering, this is even more of a problem because it's harder to finish a complete style and get all the elements in place with the current tools available to us. For example, there's no line art here because this is just an Eevee render, and Eevee doesn't really have line art capabilities. I can render out the lines with freestyle or with the Grease Pencil line art modifier, but those still need to be cleaned up and then combined with this image. And line art isn't all that's missing. I also am completely missing cast shadows from the key light because Eevee doesn't handle those well. And I want some glow, some indirect light, maybe some bloom on the sword blade and stuff. And Eevee can sort of do some of these effects, but it just doesn't do them well. So they're going to need to come out of cycles and then be combined into this. And there's also lots of little problems that need fixing, like the Rimlight is coming way too high on the hair here, in my opinion. I'd like to get rid of a bunch of this. And like, what's happening with the shading here? I have no idea what my mesh did there. I'd like to get rid of just that spot without messing up the rest of the shader. And maybe adjust some of the shading on the nose and stuff in the mouth. Lots of little adjustments. Some of these problems could be fixed in the shader itself, but my shader is already very complicated and heavy and has terrible compile times, and burdening it even more with mostly shot-specific adjustments to only a small area doesn't really seem like a great solution. This whole issue is kind of uniquely a 3D issue too, because we don't touch specific areas much. You know, we make a shader and we make a rule set that defines how things will be rendered, and we make the mesh that, gets shaded based on its properties. If we were a regular digital artist, then you'd just erase that area. You'd have a shading layer and a color layer and a highlight layer, and you just erase the bit you didn't like or that looked wrong. So I made it so I could do that. Now, I'm not really a digital artist, but I decided I wanted to have that level of control and that functionality. So I redesigned my shader to render all of the passes out as individual layers and set up a new file that brings all of them in as images on a plane. And now I was able to do everything I wanted and finish my artwork. I've got my line art and rim light in. I've got my glow and bloom and indirect light and background and shadows, and I could spot fix shading problems in the hair and face and all of these other issues. To an extent, artwork is never really finished, but at least I was able to complete the process that I wanted. And I was able to keep the whole process in Blender itself. This makes things a lot easier because I don't have to worry about figuring out how to make my whole layer stack work in some other paint software that doesn't have the same nodes. And I know how to use everything, so any adjustments I want, whether it be brightening the indirect light in the hair or controlling the darkness of the cast shadows, I just know how to do already. On top of that, if while I'm working here I find some effect or change I like, I can just go put that back in the original file because, again, it's the same nodes. Now, Blender isn't exactly famous for its painting features, but that's alright because all I was really doing was spot fixing some black and white masks, and it has enough for that. And Eevee wasn't really intended for a workflow like this, but despite a few limitations, it handles it well, and the performance is quite good actually. Every image in this file is 6K by 5K, which is a bit ridiculous, but it's nice if you want to work up close, and I had no performance issues. Here's a quick look at how some of the component layers stack together. In earlier videos, I covered the idea of paint layers like this, and also how to make an output group that lets you render out different parts of your shader on different layers. In this video, we'll be going into more details and looking at the final setup. First, we'll take a tour through the whole pipeline from shader to output to compositor, then input in the other file and see how it all works. Then we'll be looking at the details of how I actually use this artistically and what changes I made. We'll cover the relevant technical limitations of Eevee, and then get into some of the dry but important details of setting up a file like this, like bugs and limitations with AOVs, file format and bit depth and what you're going to need for different passes, how to set up a new file for painting like this, and more. And we have file releases. The shader nodes and combine nodes are both available for free, and the combined file and even the original 3D model file can also be acquired for a small amount. Let's take a tour through the whole pipeline so that we can understand how it works, starting, of course, with the materials themselves. There's a bunch of different material assignments on this model. They vary in complexity. Some, like this, have all sorts of procedural textures and colors and stuff. But what they all have in common, except for the lights, is this shader group shell. This manages the shaders and the output to different layers, all from one central place. The inside of the shader group shell will be familiar to people who have seen my previous videos. There's even a link to one of them. The Toon shader and Cycles shader groups were covered in my earliest video, but have been updated a bit since. And these layer out management groups were covered in my previous video to this on rendering different materials on different render layers. The Toon shader itself has gone through a big reorganization since my original video, but it's all the same conceptually. On the left here, we have the actual shader node groups with the diffuse shader node in it, giving us a shading layer and a hard Toon shading layer, and then some gloss related stuff, the actual gloss layer, and then a boosted Rimlight layer that I've called specular, and also the Fresnel that's used to mix the two together. Those shading layers and also all the various colors and other inputs then go into the combined passes group. This is where the whole stack is actually combined together to create what we see here. The different shading layers are multiplied together, multiplied by their colors to color them, adjusted by Fresnel, the diffuse and gloss are combined, and then various extra things are added in. That combined pass is then output from the combined group and also the main shader group, and so are all the other individual passes, because they will each be output separately. They'll be rendered out as individual layers, saved out to files, and then brought back into a new file as image textures and combined there. The layers out group controls what passes are going to be rendered out on what layers. For passes that aren't shader based, like just colors and values, AOVs are used. You can put all of your AOVs in this one group, and they'll only render out on layers where you've also defined them in the View Layer Properties panel down here. In this case, I've only done it on the data layer. The other layers output with emission shaders using the connect group that was covered in the previous video. This is the one that switches what's hooked up based on the number at the beginning of a render layer name. This looks pretty weird because what we're actually looking at here, if we take a look at what's going into layer 1, is the Toon shading and the regular shading as the R and G channels being combined. Those of you who watched my previous video will remember that I had two different types of groups, one that switched the actual connected sockets and one that mixed between different nodes. And in this case, I've combined them both into the same group, but with different outputs. So for Eevee, you do need to use the connected output, not the mixed, for various technical reasons related to how much Eevee can combine into one render layer. There's lots of technical issues overall, both with Eevee's AOV system, which is buggy and unreliable, and also with how you output any shading that goes through a shader to RGB. So all of that is talked about in the previous video. On the cycles side, we also have the cycle shader group, similar to what was talked about in my very first video. And its layers outgroup is much simpler because we're only doing an indirect and a shadow pass from cycles. So in this case, I am just using the mixed output because for cycles, it doesn't matter. We have the cycles layers set up in a separate scene because you need a different scene to have a different render engine. It might be possible to use a script to check what render engine is used by layer, but I haven't experimented with that yet. Managing multiple scenes is usually annoying, but in this case, it's not difficult. The cycle scene is just an instance of the camera, and then collection instances of the character and the floor in this case. The thing that can be annoying about having multiple scenes is that the render settings are different in both scenes, and they can get out of sync. For example, you could end up with a different resolution in one scene from the other. So anytime you change something in the main scene, you have to flip over to the other scene and change it as well. But I've gotten around that. I have a script, which I will be sharing, that keeps the resolutions in sync. It's very easy, and this is just registered to run when the file loads. So now, even if I change this, it didn't change. Well, actually it did change, but it was immediately changed back to match the resolution entered in the Eevee scene. The first cycles layer is an indirect only layer. The lights are set to only show indirect lighting. This is a trick that I first talked about in my ray overview video. We can't actually select the light to see the nodes well in the scene itself because they're inside this collection here. And boy, does it render slowly. So let's kill that. If we flip back to the Eevee scene and select our key light, then we can see that I've also got different Eevee and cycles outputs for my lights. And on layer 0, I've got just an indirect setup. So it's using light path and ray depth to basically not count the first light bounce. So only things after the first count, hence indirect light. The second cycles layer is very simple because it's just for getting the cast shadows separate from the shading. And that means its actual shader is just a white diffuse. And we do the rest in the compositor. Speaking of the compositor, that is where everything eventually ends up when we hit render. On the left, we have all of our render layers, including the cycles ones. Then everything flows into one central group for routing and for making any changes, and then to output nodes. And I have a different output node for each render layer so that I can turn on and off the various outputs based on what layers I'm rendering. If I'm just re-rendering one layer and I leave everything on, then it will override any other images in my render folder. Speaking of the render folder, it all ends up coming out looking like this. And we can flip through everything. Alpha, we have the combine just as an example. Indirect, just the shadows. I output the Z pass just in case I want it. Diffuse color, diffuse shadow color. The emit pass, which I'm not using in this project, so it's just black. I've got freestyle, which I didn't have enabled before. Fresnel, gloss, gloss color, gloss shadow color, glow, line color, which all the lines are black, so it's all black again. There's nothing in this lines pass. I don't have any line art defined in the material, so it is white by default because it gets multiplied. And then there's a bunch of masks for different areas. And also the normals, because why not? Shading, the Rimlight, which I've called specular because it could also have things in it that aren't Rimlight, but it doesn't at the moment. And the Toon shading. And the world color. And back to the beginning. The modifications actually happening in the compositor is mostly splitting up the layers that were done as RGBs. So those are separated, and the masks are mostly coming from Cryptomatte. And for cycles, that shadows layer doesn't actually use the rendered image. It's just using the shadow pass, because the shadow pass just gives you the cast shadows from the enabled lights. If there's just one light, it'll be a black and white mask, which is what we wanted. You can see that there isn't actually any shading here. It's just the occlusion shadows. If you have multiple light sources, though, then it would have areas hit by no light as pure black, and areas that have shadows on one light but not the other as gray. So it's important when using this method of isolating shadows that you only have the key light casting any light, which is what I've got. All of the files output to a common render folder. But before combining it, what I do is I make a new subfolder that will contain the actual blend file I combine the images in, and I copy that rendered layers folder and use that as the input. This way, if I'm doing re-rendering, I don't necessarily overwrite the current images I'll be using, and I can make copies of it to save various different states. This folder also contains the blend files where the images are recombined, and the finalization and post-production stuff is all actually done. This new file consists of a simple plane that matches the aspect ratio of the images, and then an orthographic camera that matches its bounds. All of our images are brought in as image textures in a material in one group. They go through whatever transforms we want to make here in the middle group. Then they go through the same passes combine as in our material. It's just the same group re-imported. And lastly are just outputted with alpha. And it all combines together to rebuild our render just on a plane. Other passes like the lines and the Rimlight are brought in as their own layer, which lines up perfectly with a orthographic camera. And then there's also glow and a background. Each of these just their own plane canvas with alpha overlaying them over each other. So what we have is essentially a compositing setup and a digital painting layer stack rolled together, but still using our same familiar Blender nodes, and without having to jump through the hoops of an external program. We can access all our various different passes individually as images without the overhead of compile times if we worked with this in the shader itself. And even working with very large 6,000 by 5,000 images like I am, the performance is actually pretty good even when painting. The whole setup is very flexible and generally non-destructive. All of the changes I'm making are just nodes acting on input images, or even when I'm painting something, it's a new image overlaying the original input image. What this means is I could go and edit these images in a third-party program if I wanted, or if I make any changes in the base file or in the shader, then I can just re-render at any time and it just fills the images in. And since it's the same nodes, if I figure out a change I like, I can just go back and add those nodes into the original shader stack and keep things here simple, which I did a lot of in this project. Let's go through exactly what effects and changes I have set up here. Connect to my debug socket and make that the only thing we're viewing. Here we're looking at just the cast shadows pass that I rendered out of cycles. And if we look at what it originally starts as, it goes to black almost everywhere except for a few gradients. But that's a bit too harsh on the hair. Hair is supposed to be, partially transparent, and if it was proper like particle or strand hair, it wouldn't really pick up that much of a cast shadow. So this effect reduces the darkness of the cast shadows in the hair only. And it does that by masking the hair and the face. Let's see, it's affecting the face too. The shadows cast by the bangs onto the face. And then this control is controlling how dark it goes. This second map range node can also be used to adjust the darkness, and for example, can be used to eliminate the non-black areas here, or to lighten everything up. But I didn't end up actually using it for anything in the final mix. Next is the Toon shading layer, where I made some very minor changes through texture painting. I can disable them with this slider, and you can see that in the hair, some extra bits of shading have been erased. This image texture is being overlaid over the original pass using alpha. If we head over into texture paint mode, we can see what it actually looks like, which isn't much because it's mostly just white being painted over some areas and black painted over others. going in rendering, I've got this set on single image with the paint over Toon image selected. And if I grab my tablet, I can just draw new stuff into the shading layer, or switch to white and erase existing stuff in the shading layer. Currently, it can go outside the image because there's no alpha or mask, but even if I painted outside, if we plugged in the full combine layer, the alpha mask would stop this from being visible. And of course, if we want to erase, we just need an erase alpha brush, and that gets rid of things cleanly. And of course, most tablets have a erase button on the stylus, or you can configure it on the tablet itself. So you could draw something, hit your eraser button, go into eraser mode without even having to switch the actual brush in Blender itself. Blender's paint tools aren't as advanced as we'd like yet, but we do have plenty of things to work with, like palettes for different colors. You can set up stencil masks, and we can select our existing masks if we want to limit something to just one area. And of course, we can hit S and eyedrop different areas if we were trying to paint in different colors or different amounts. And when you use that tool, you can set it to sample what you're visually seeing when you're rendering, or to just sample what's actually on the texture. And if you want some more controls, if you're not looking through the camera, but get out of it by rotating or hitting numpad 1, then there are hotkeys for rotating your camera that you can map to tablet buttons or whatever else. And of course, zooming in and out and brush sizes. Of course, just editing a black and white mask doesn't really give us the full context, but we can plug in the entire stack and have everything running while doing our paint into just one layer. The performance of it all holds up well too. Eevee's come a long way in brush performance. If I make a giant brush and paint across a ton of stuff, then I get some brush lag, but even just a medium-sized one has no performance problems. And this whole stack is like 20-something 6,000 by 5,000 images. So you'll have similar problems in other paint programs with this heavy of a stack. Let's get back to our other changes. We've also got some adjustments to the non-Toon shading layer. We can turn those on and off. You can see mostly I have removed some of the darker spots and details in the hair. And if we zoom in, my painting here isn't very precise, but it doesn't really need to be because there's enough layers that little problems like that won't be noticed. There's also some changes to the shading in the face to have a little bit less on the cheek and refine the nose shadow a bit. For the gloss paint over, again, basically the same sorts of changes, removing some detail from the hair and refining the shapes in the face. So fairly minimal changes from the paint over in this piece overall. I'm not going anywhere near as far as you can with these layers, but I didn't really need to. Something that is completely new, though, is these border lines between colors on the diffuse pass. Usually the diffuse pass looks like this, with my pattern texture, but no line between. These lines were actually made in Photoshop by taking that diffuse pass and just running it through an edge detection filter. So very simple to do. Lines like this could have been added into the textures itself, but those nodes are already very complicated, and getting that line would have increased compile time on the materials by a lot. So maybe I'll go back and add that kind of thing into the original setup, but this was an easy and fun way to play with a new effect without spending like an hour waiting for things to compile. The area where I did the most changes in post is the indirect lighting pass. This has a paint over layer where we can see again reducing detail in the face and adding a little bit of size to this big highlight on the leg and arm. But most of the changes come from these RGB curves. I used various of my input masks to make it so that I can control the hair, the face, and everything else separately from each other. The RGB curve itself is boosting the strength of the indirect light and essentially making it brighter and affect a wider area. Then here I have a map range group, which is just map range nodes, but on separated RGB, so you can do it on a color channel instead of the usual black and white only. And these are capping the maximum brightness. And there's similar settings for the face. And everything else. And this is the sort of thing where you really want to be looking at the full combined stack while you work on it to get the full effect. Let's check those face and hair changes again now. It's a very subtle effect on the face, actually. And now we can really see what the contribution is. I've got lots of blue light. In the cycles layer, the hexagon texture is emitting light onto the hair. So that's where a lot of this indirect pass is coming from. The last thing left in this group is just this world color group, which I use in a few different places. And this is just an easy setup because there isn't any fancy world texture going on in the original file. The world color is basically just determining how dark the shadows go and shading. So if the world color is 0, unlit areas go to 0. Then as you turn it up, it's increasing the brightness of places that are black in the various shading masks. So it never increases brightness of fully lit areas. And that's just how I've decided to implement it in the Toon shader. But since it's just a flat color, there's no reason not to replace it entirely in the paint over setup. Next up, let's take a look at the line art. The line art actually starts out as grease pencil lines generated by the recent line art modifier that was added to Blender. What's great about these is that, of course, you can edit them in edit mode, or you can edit them with sculpt mode. You can draw in more with your tablet, or you can draw in things with the existing curve tools. And then, of course, it's got a full stack of modifiers and effects. Here's how it looks after I cleaned it up. I broke all of it down into layers, and I added modifiers that could control the thickness in various different areas, such as adjusting just the hair layer thickness, so that I could just adjust things and see what it looked like and get an idea of what I wanted. I had the general idea that I wanted external silhouette lines to be thicker and then internal lines to be thinner, and for lines in the hair to taper a bit. I've also got a very slight blur on, which doesn't make a huge difference at full distance, but does help a little bit with some of these line tapers. Some of these could taper a bit better, but, you know, I'm already doing this by hand, so I didn't want to spend more time than was necessary. The tapering was done with sculpting and also with proportional editing. Once I was satisfied with it, I rendered it out to an image so that I could properly make the rest of the line layer and mix it with other sorts of line art. This layer also contains specular, which I'm going to disable for a minute so we can just look at what's here. I've added lines that are at the edges of the Toon shading and cast shadow pass. These were also made in Photoshop with edge detection filters. On their own, it looks like that. Photoshop filters are notorious for having really bad aliasing and blurring and stuff, but when you're working at this high resolution and then your final view is going to be, you know, here, then all of those issues pretty much just disappear. I've also got some controls here where I can, you know, disable them or adjust exactly how dark they are in different areas. I knew I wanted different amounts of darkness in the skin versus the rest of it. And of course, I don't really want any area to be full black. So again, the point of this setup is to be able to build a setup and parameters and then adjust some parameter until I like the way it looks. I've also got a paint over layer where I did erase lines in some places, and this layer is covering both the grease pencil lines and the filter lines. So getting rid of some of the hair and actually thickening up this little bit of the hair that I didn't make thick enough on the grease pencil part. And a few changes in other places. I see I missed a little bit of, that's not the greatest shape there. I missed some spots, but that's fine. On the Rimlight or specular side, I called it specular because I originally meant it to be things that are just turned all the way to white, but I only ended up using it for Rimlight, so the name doesn't really matter. This has a paint over layer where I get rid of some of the internal lines that are coming in on the hair. And the reason that was necessary is I made it so that the hair itself does not cast any shadows to block the backlight from rim lighting the body. But that also means the hair doesn't occlude itself. So internal edges are picking up rim light that shouldn't really. And I've got a curve, we can boost the amount easily. Oh, it starts out pretty soft at that, but I've got it boosted up. And if we turn the lines back on, I wasn't sure how much I wanted the rim light to be covered by the lines, or do I want the lines to cover the rim light? And since I wasn't sure, I built this control for it. So here, this is now masking the lines out wherever the rim light is. And in some areas, it's a nice effect, like I like it on this shoulder here, where we still have the part of the line art that's outside the bottle, but it really lets us get that nice, strong backlight, rim light on the shoulder. But in other places like the cheek, it doesn't work out so well. And the side of the hair here. Now, if I spent more time working in my paint over passes, I could have gotten this working. But in the end, I decided to just not actually use this effect for this piece. The rest of this group is just a setup where I can control the rim light color if I want. And again, I haven't used that, but let's take a look. If we wanted to go really crazy, we can turn everything back on and make our rim light red, or there's lots of fun stuff you could do with this if you wanted to. And the rest of this group is just putting together the proper alpha and stuff for each, because this layer needs to alpha over the layer below it with transparency. And this is using alpha blend. One of the limitations of working this way is that, unlike a regular paint program, you can't tell this layer to be, say, a brightening or a multiply effect on the layer below. You're just dealing with alpha over. The glow layer is also just alpha'd over. And I'm not going to say too much about it because I'm not actually too happy with it. In Eevee, of course, you can use bloom, but bloom doesn't play very well on complex combined images like this because it is threshold based, and there's no way to tell it to not affect certain areas. So like, I want to bloom the sword blade and the scabbard here, but by the time they're getting hit, it's destroying the skin. So if you want to use bloom and have control over it, what I did was I actually rendered out a separate bloom pass, which looks like that. And I also have my glare node compositor glow from the original render. And then I put them together and did a bunch of ramping to them and stuff. Because basically what I was trying to do is get like a color glow where it's mostly a blur of color. I didn't want it to be too bright, because this piece isn't really dark enough for bright bloom. But I did get my nice sword bloom and a bit on the headset. And that's because those parts I kind of just painted in the end. So yeah, I want to say about the glow and bloom. I'll have to return to that one later. But the process does work. I'm also not really going to talk about the background too much, as I really have no idea how to do backgrounds. I just went for some kind of abstract stuff. It's a bunch of procedural textures mixing between two colors. And then I guess the interesting part is I rendered out the floor shadow with cycles with a floor catching plane in the original file. And this shadow doesn't actually line up with the real key light. The real key light has the shadow going back and like off the screen. So I just used a different light and rendered the shadow off as a one-off render so I could put it artistically where I wanted it to fill that space. So I'm not sure if that's a good thing to do artistically, but it's similar to stuff I've seen other artists do, and I wanted to try it out. I've also put a filter edge on the shadow and then blended it out with some noise texture if you look closely. And the background lines themselves is actually just some Bezier curves I stuck back there. So yeah, not much to say about that, but easy to do whatever you want. Now that we've seen how it works and how I'm using it, next let's take a look at the limitations of this setup. Considering that this isn't really an intended use of Eevee, there are surprisingly few limitations. First up is a problem with Grease Pencil and layer display order. Let's disable our regular line layers and look at our Grease Pencil line layer that is actually still a Grease Pencil object. And now let's move it back behind the character. And it's still on top. And let's move it all the way back behind the background. And it's still on top. And of course, we can set an object here to always be in front, but that's not actually enabled. So what's going on? Why isn't this front plane occluding it? Well, let's select our background canvas plane and under the material settings, change the blend mode to opaque. And now it's properly blocking the grease pencil. So what's going on there? I guess we can move it forward and it's still behind our character and our character is not occluding it. So if we change this blend mode to be opaque, now the character does occlude it, but then we've just lost our alpha. So if we're using alpha blend, the grease pencil shows through. If we use alpha clip, now the grease pencil does get occluded by the character, or if we use alpha hashed, it'll get occluded by the character. Of course, I do actually want these lines on top of the character. I'm just using it as an example, but there are other things that I would like to use on top of the grease pencil, like my glow layer and my Rimlight, and currently none of that works properly. And that's because of this issue. This is specifically a known issue with Grease Pencil and Alpha Blend mode. Now, Alpha Blend isn't the only way to use Alpha, but it is the one we want in most cases. Alpha Clip looks at the alpha mask, and any area where the alpha is below a certain amount, it just cuts it off. Whereas Alpha Blend lets you have a gradient of transparency. So on the character itself, we could use alpha clip because the alpha mask is either, outside the character or not. There's no transparency in the character itself. But if we look at something like the glow layer, if we switch to alpha clip, then it's going to be a mess. We don't get that gradient of transparency that we need. Now we can sort of get it if we use alpha hashed, which does give you a gradient, but is incredibly noisy. So I don't think there's any way to really clean that up either. So at the moment, there's nothing you can do if you want to have a gradient of transparency on top of a grease pencil object visually. It's just not supported. But hopefully in the future, it will be. They need to add some sort of depth recognition to the grease pencil objects. Next, we have a technical limitation of Eevee, which is that it only allows you to have a certain number of image textures per material. If you go above the allowed number, then they'll just start outputting pure pink, the same as a broken or missing texture. Exactly what the image limit isn't clear because it varies by hardware. I've made it to 30 images in one material before I had any problems. And I'm using a GTX Titan, which was a really fancy card in 2016, but most modern cards that are, middle-end cards are on its level or better these days. So you'll have to test for your own hardware. You can test by just dragging a ton of images into your material and hooking them all up with mix nodes and seeing how far you get before it starts turning pink. And of course, this setup is pretty complicated and not entirely optimized. A bunch of these passes could be consolidated into just a single RGBA image. All of these masks, you could put 4 of them in one RGBA image, or the shading layers, for example. So if you wanted to reduce the image count without really changing anything else, you could combine more in the compositor after rendering, but before file output. And also there is talk going on about restructuring a bunch of how Eevee handles images and layers and stuff. We don't know what the details of that would be yet, but it is supposed to improve paint performance and possibly image limit, stuff like this. So we'll just have to see what happens. Similarly, you'll need to keep an eye on your VRAM usage. I'm at 6.7 out of 12, and that is a lot. My system takes about 1, not counting whatever Blender is doing because of all my monitors. And 6.7 is high. You know, a lot of cards don't even have that much. But the reason it's that high is because I have like 46K images here, and all of that gets loaded into VRAM when rendering. So if you're not doing totally crazy resolutions, you'll just never have this problem, because if you have even half the resolution of these images that I do, you'll be using like half or less of VRAM. So another issue that could matter, but you'll probably never run into. And the last main limitation is really just a artistic thing that it would be really nice to have, but we don't. I mentioned before, when we're dealing with these different layers, since these are just textures from planes, we can't have it blend these layers in different modes visually, like we would with layers in digital painting. So you do have to keep in mind, you only have alpha over to work with. You can't have like this glow layer be a screen effect or an add or a luminosity like you would in Photoshop. So if you really want that functionality, you will still need to go to a fancier, proper paint program. But maybe we'll even get that one day. There's a lot of things I found while working in the paint over file that I then went and fixed up in the original file so that those changes will be permanently implemented for any other poses. But there were also a few things that were easier to do in the shader itself that were just for this pose and would have to be redone for every pose. The biggest of these is the hair bevel texture that is reducing detail and curvature in the hair. Let's turn some of that off. And if I disable this texture for a minute, we can see that the strands of the hair become much more visible. This is reducing the detail in the hair and making it a little less obviously 3D, cleaning up these intersections and like some of these gradients suddenly ending. And this is done by taking the cycles bevel node over here and baking out separate beveled normals. If we look at the normals directly, we can see the difference easily. This is the original base normals, and then this is the normals after being affected by the bevel. Everything kind of blends together. The actual map looks like this. Now, I didn't use a tangent normal map, which is the normal type, because it's a lot harder to get that to bake beveled normals cleanly. A object space is easier, but it only works for one shot. But you'll have to rebake a tangent map every time the hair change pose anyway. So to properly use the object normals, you do have to put it through a map range to map it back to -1 to 1. But that's pretty much it. They're pretty easy to work with other than that, and they don't even need a ton of samples. The other change was also to reduce detail in the hair, this time in the gloss layer. Using my shader's override system, I overrode the gloss layer in the hair. The default settings, we can see that there's quite a bit of curvature being shown by this gloss. But once we turn this on, that disappears. If we look at the gloss mask on its own, we can see the effect clearly. Here's the base gloss, and then as we turn this up, it just obliterates all that curvature by setting it to a flatter value, well, a flat value, based on a gradient from the tips to the roots. So the tips get to have the regular gloss, and then the roots are flattened out. And this is done with a clamp and a map range. So we can adjust these to allow more through, but we're leaving it at a pretty low value. And then this is controlling the gradient. So when we turn this up, we can see where it's affecting. All right, so we've made it this far. We summarized how the pipeline works, and we looked at what I actually did with it artistically. So now maybe you're thinking you want to try setting up something like this for yourself. So the rest of this video will be about a bunch of the technical details that go into actually making this all work and not break. All right, so first weird issue. Remember much earlier I said that AOVs are unreliable and buggy? Well, I'm going to show you a really wacky example. So we're looking at the dress material and we're looking at the specular pass on the specular layer. And you'll note what I've got here is this big procedural textures for the hexagon pattern and the dots mask and some other stuff. And it all combines into a RGB and passes through, and then it uncombines. And what's going on here is, since these textures were so complicated, I baked them to an image, and I have this separate RGB for separating them out of the image again. And I'm not using the image right now because it doesn't look as nice, and this is a high-res render, so I'm just using the originals. But I routed everything through these combine and separate RGB, and that shouldn't matter. But it turns out it does. If we look at the sleeve, you'll notice that for this bump map height, I've plugged it in from here instead of the same thing having passed through the combine and separate RGB, and same with the leggings, and these are separate materials. Now on the dress, I plugged this in directly. This is how I originally had all of them, and I'll show you what the problem is. The context I originally found this in is before I didn't have separate gloss and spec layers. I had spec as an AOV output on the gloss layer, and here I've recreated an AOV on the spec layer for it. And in the viewport, everything looks just fine. Now let's flip over into the compositor where I've rendered this out, and we can see our specular layer. There's our rendered image. Everything looks fine. Now let's look at the exact same thing coming out of an AOV. And what the hell? My hexagon pattern is showing up all over the dress. It's not properly masked out. At first I thought this was an inversion of the mask I have, but it doesn't even match that properly. So I have no idea how this got this way. If we go back into the shader and we look at our output group, there's the AOV, specular going the AOV. Up here, it's just specular going in an emission shader. It works in the viewport, should be the exact same thing, but the version coming out of the AOV is just wrong. And it's wrong in a way that makes no sense at all. Like, I don't know how a height bump map or whatever being in a different socket does this. Now we will fix it and change the nodes back to being like all of the others and re-render. Okay, we've re-rendered and now the AOV version works. So, problem solved. Why? I don't know. Also, I just noticed something on the face is different. Yep, very slight different face for the AOV version. I don't know why that is. I never noticed that before. I had stopped using the spec as an AOV because I wanted it on its own render layer to re-render anyway. Anyway, the point is, I'm showing you this. Don't trust AOVs with anything more complicated than like an RGB color. So, AOVs, whole can of worms. Next, let's go a little further into detail on what's going on in the compositor. I've got this pass router group, and there's a bunch of things going on inside it. First of all, if I had freestyle enabled, it would be rendering off the combined layer and then coming in here to get a slight blur, because freestyle generally is a little bit harsh on the aliasing. This is an old trick when using freestyle. I've also got my glow mask being generated by the glare node here, which we're looking at, but as I noted earlier, it's just not that great. If you really want nice glow, get it from Photoshop or something. Also, for the depth pass, that is worth taking and normalizing, because if I want to use it in post, I do want it to be something that I can visually see. So when it's normalized, you can actually see it, because it's crushed it between 0 and 1. Whereas without the normalize, then you don't see anything because it's giving you the actual distance in Blender units to the target thing. So as I'm mousing this around, we can see our color values like 5 or even much higher. So normalize your depth pass if you actually want to work with it. And another thing I'm not using but you should know about is I have this whole layer for if I had texture-based line art or material-based, which I don't because I did everything with Grease Pencil and filters. But a lot of the time you will, and an easy way to output that is in the shader nodes, in the output group, I actually invert it, and then I uninvert it in the compositor. And the reason for that is the line mask tends to be black. You'll have black lines and everything else will be white. So if you just render that out normally, what's going to happen is what happens with these other layers, is everything that's not on the character model is going to be black. So you'll have a black background and then black lines on the character. So then if you're using this later on, it's going to you're going to have this big black space around your character, which will mess things up when your alpha isn't enabled, which will confuse you. So you invert it and then uninvert it, and that will mean that it will rendered out as a white on black mask with a black around it, and once you uninvert it, then you'll have white everywhere except for black lines. A major area you have to watch out is what format you output your images as, and what bit depth. For example, we're looking at the Fresnel pass right now. Here it is. And in the file output node, if we go here, we can see it's not using the node format, it's using black and white at 8-bit. So let's just save this out really quick on my desktop, black and white 8-bit. Saves out. We take a look at it. Looks exactly the same. Beautiful. Now let's look at the version in my render folder that actually saved out from the file node. Not the same. It's totally darker. It's the exact same settings. Why is this different? I have no idea. This is some file node issue. But actually it doesn't matter, because if we go into the paint over file and take a look at the Fresnel, it looks correct. Why? Well, if we look at the texture node, it's on non-color data. If we put it to sRGB, which is the default, now it's wrong. Non-color data, it's correct. What the hell? But it actually gets weirder. I've saved the Fresnel out again as both a EXR, 16-bit, because it's only 16 or 32, and as a JPEG 2000, 8-bit. And we go into this file where I've dropped them in. They've defaulted to linear for EXR, because EXR just avoids all these problems. It just looks correct. If we put it on sRGB, now it looks wrong. So linear for EXR is basically the same as non-color data for other formats. But for the JPEG 2000, it looks correct on sRGB. And if we put it on non-color data, it gets even brighter. So it's all sorts of weird. And I won't run through it all, but actually, if you render it out in some formats at 16-bit, it doesn't need non-color, and at 8-bit it does, and there's all sorts of weird stuff. So you've got to watch your formats. And basically, the rule of thumb is just use EXRs for everything if you want to not deal with this problem. But the problem with that is a lot of operating systems won't be able to view EXRs like as thumbnails or open them in a preview app by default. You actually have to get a codec pack to do this. And basically, you're going to spend money if you want it to not be terrible. So if you want to use more convenient formats like PNG, which has a bunch of problems, make sure that if you're using an 8-bit PNG, you need to set it to non-color when bringing it in as a texture. Sometimes. If it's pure black and white like a mask, you don't. And a bunch of other things I've done here, like my actual shading layers, they're just on sRGB and there's no problems. Like, this shading layer looks the way it's supposed to. If we look at the rendered version, it has not been distorted. It didn't go dark like the Fresnel. Why did the Fresnel go dark? Who knows? Why did the shading layer not? Who knows? But you got to watch out for this stuff. And that's not the end of oddities with output formats. Let's take a look at my gloss color pass, and you may notice here, it's all PNGs except gloss color is an OpenEXR for some reason. And not all of these PNGs are exactly the same settings. They're not, some, are RGB and some are black and white. But the gloss color stands out. So why did it need to be an EXR? Well, the reason is because I am breaking all sorts of color rules in my shaders. If we take a look at the shading graph, this is the color group, we can see that for the bangs and esotropy highlight, value 25, and for the hex pattern edges, value 15. What this means is that the gloss pass has values in it that go way above 1, because I was just adding tons of extra brightness. If we mouse over here and take a look, we can see that most of this gloss pass, the values are about 1, give or take a few decimals. But if we go to the bangs highlight, the values are like upwards of 2 or even 4 on some of these, or 5 there. Also, if you mouse around here, we can't see it because it's white on white, but the actual hex pattern is way brighter. It's going up to 15 on blue there and 8 on G. So doing this is fine if you're just, adding things. It doesn't hurt the color mix, but it does make this pass not really human readable because it's white on white. So what does this have to do with EXRs? Well, basically, in layman's terms, what it means to use 8 versus 16-bit is that 8 only contains values between 0 and 1, 8-bit images. So if you have values below 0 or above 1, a proper HDR image, and you save it as an 8-bit, those all just get cut off. Like a value of 5 will be clamped to 1. So we can't use an 8-bit PNG. So we need to use 16-bit. And 16-bit PNGs don't compress as well as EXRs, whereas EXRs, your options are float half or float full. Float half is 16-bit and float full is 32-bit. So if you need to use a 16-bit image at all, just go straight to OpenEXR. You can use other formats like JPEG 2000 and stuff, but EXR is just the easiest thing to do. Otherwise, all that additional brightness ends up getting lost. Now, hopefully at some point in the future, we'll just get the ability to save things as a multi-layer EXR. If you save as, see, multi-layer there, if you do that, what it will do is give you one single file that contains every single pass, every single output from all of your render layers. The reason we don't just do that now is because Blender can't input those in the material editor. It can reopen those in the compositor, but not in materials. It is support that they're talking about adding. And that might also get us around Eevee's image limitation for all I know. So let's just hope that comes to pass. Another area you have to watch out for strange or counterintuitive behavior is with collections in other scenes. Here we're in the cycle scene indirect layer, and we see we have our character and we have a floor. And we also have a different floor collection that is disabled visually. So it's not this floor we're seeing, but here's also a render of this, where we can see that there is no floor in the render. We've got no bounce light coming up off the floor to the character, even though this floor is a gloss shader. If we flip back over into the Eevee scene, which we have an instance of, we can see the floor does exist in the Cybergirl collection that is instanced on the cycles layer, but it's not enabled, and it's also hidden. So if it's hidden, but enabled in render, what are we seeing here? Let's go back there, back to the indirect layer. So this floor is in the Cybergirl collection, it's hidden in the main scene, and it's hidden in the viewport and enabled in render. And yet we're seeing it in the viewport where we shouldn't, and we're not getting it in the render where we should. And now it's gone. I toggled the visibility on this layer, and it fixed it. I'm not sure if it's there if we render it now. Let's try it. Okay, I re-rendered, and as you can see, now we have tons of indirect light coming off the floor. So it's now properly disabled in the viewport and visible in render. But that's all kind of a pain because this is so unreliable. So what I'm actually going to do is just disable this entirely, and that's why instead I made a separate instance on this layer of the floor where I can control it properly to get around this issue. And you can have this with all sorts of weird things. I'm not really sure how it's supposed to work. I haven't been able to find anywhere that says how sub-collections are supposed to behave in different scenes when instancing the main collection. You can do lots of useful things with sub-collections, though. I've got this disabled on the combined layer, and I can go and re-enable it on the shading layer if I wanted it there, and those don't interfere with each other. Then I do need it to be enabled in viewport and render for that. But how does this affect the cycles layer? Let's take a look. If we get rid of this and this, now it does seem to be there until I toggle that again. So basically it's completely unreliable and Blender is doing some weird thing. So if you're working on it with a sub collection on another layer and it looks one way and then it's rendering wrong or something, just remember there are these issues, and the way you get around it is you just re-instanced it. Something else I mentioned earlier is that the lights have their own materials. We can see here they've got their own Eevee and cycles outputs. So for the key light on layers 0, it's using indirect only for the cycles output. And on layer 1, it is using the full emission. That's what's going on in this group. And for the backlight, in Eevee, it is just on all the time. And then in cycles, it is disabled. It's just black. So if we go over to our shadow layer in the cycle scene, we can see why that matters. And we can't actually access the lights anymore because they're nested inside the Cybergirl collection. So we would have had to have pinned the material to keep changing them. But the reason that the Rimlight is disabled this way is that there isn't an easy way to disable it on this layer because it's nested in the Cybergirl collection. What I could do is pull my whole studio collection out of the Cybergirl collection and then manually instance that on the other layers where I need them as needed, and I could make sub-collections of that for Rimlight and backlight, but I decided it was easiest just to keep everything in here and just kill its ability to emit light on those layers, because we have this mix group that's going to do that for us. If we didn't have this, then we would have to juggle all sorts of collections to get things working right on different layers. The next highly unintuitive thing is how to take our grease pencil lines and get them into the paint file in the right way. In the paint file, our grease pencil lines are a beautiful flat layer that is facing forward on Y and works with an orthographic camera. But in the original file, these are the grease pencil lines as generated. They're not flat. They are placed on the mesh where they were generated, projected from the camera. You were the active camera when you ran the modifiers. So we need to get them flattened and oriented correctly without distorting them. I've got the flattened lines in the original file, and if we look through the camera, they still line up perfectly with the model. Well, not perfectly, so I don't have subsurf enabled right now, but that doesn't count. So how do we get them like that? We're going to reproject these lines. First, I'll take the original grease pencil object and duplicate it, but you have to watch out when working with grease pencil objects. That was a Shift-D duplication. When we do that on a mesh object, we're used to it also duplicating the object data, but for grease pencil, for whatever reason, it doesn't. So after you duplicate it, you got to hit this to have a new copy of the grease pencil data as well. Otherwise, any changes you do will also affect the original object. Next, I'll make sure that the origin point of my grease pencil object is at 000, the world origin. And if it's not, you snap your cursor there, then you go to Object, Set Origin, Origin to 3D Cursor. Once it's there, we can go into Grease Pencil Edit Mode, have ourselves looking through the camera, then do Grease Pencil, Clean Up, Reproject Strokes, View. And now they are flat, and they still line up with our camera. Now, these still aren't quite lined up correctly to the world axes. It's tilted back, so we need to compensate for that tilt. And one way we could do that is figure out what it is based on looking at our camera. In this case, my camera is at 85 and has no other rotation here. So I can deduce from that that I need to take this object and rotate it forward 5 degrees on X to make up the difference. And now it is totally flat. But there is an easier way than that, especially if you're dealing with a camera that has a much more complicated rotation. Let's start a new blend file, and I'll show you how we get the initial setup for our canvas and all that. The first step is to append the camera from our character file, and not the camera data here, but the actual camera object. There it is. Now, we're not worried about our resolution or anything like that yet. We just want to look through our camera and go to Import Images as Planes, which is an add-on that comes with Blender. It's probably enabled by default. And I'm just going to grab my combined pass from my render layers folder. Make sure offset is 0 and set it to camera. Fill or fit shouldn't really matter. We don't want to distort the plane, so just fill, I think. And then import. And now it has brought our plane in perfectly oriented towards our camera. We can see the rotation of our plane is also 85, which matches the rotation of the camera. If we had some weirder camera rotation, the plane would still be aiming right at it. If we render now, we can see that our image is on the plane, but it's not really displaying right because it got a principled BSDF by default from the import. So let's just hop over to shading and plug that into emission and come back, and now we see the full image. And we can also see that it's not really lined up with the camera correctly either. And that's because the camera has a bit of X offset that the plane doesn't have, so we'll give it that, and now it lines up. And then the next step is to append our line art, which is down here somewhere. And look at that, it lines up. It is in line with our plane and camera, even though it's flat, and both have a bit of rotation matching the camera's angle. To fix the rotation, what we'll do is get our line art and parent it, keeping transforms, to the plane, because the plane has rotation on it. Now if we set this to be 90 degrees, matching everything else, it rotated the grease pencil with it. And now we can unparent it and keep the transformation, and there's our grease pencil layer, properly oriented. It's kept that 5 degrees of rotation, or we could just apply the rotation and scale. That will work as well. And now both of these are lined up on the y-axis. The last part of our setup that we need is a proper orthographic camera. So we're going to take our plane and curse it to selected because its origin point is conveniently in the center of it. And then make a new camera, move it along Y, give it 90 degrees of X rotation and no other rotation, set it to be orthographic, and do Control Numpad 0 to make it the active camera and look through it. And now we need to get set to the right size. We enter the image size as the resolution, or any resolution of the same aspect ratio, and now the bounds of the camera do match the size of the image. Then we just need to have it be the right orthographic scale, because orthographic cameras use scale, not zoom. We can try to eyeball it, but the exact right amount is simply taking the X dimension of our plane, copying that, and setting the camera scale to match that. Of course, we could instead change the size of our plane. We could scale everything. We could have left this parented and scaled it all, because the scale right now is kind of arbitrary, but this does match up properly now. We can also, select everything, parented it to the plane, and then set this to be at 0 so that we don't have this other random offset. And now our setup is complete. We can look through the orthographic camera and render, or we can just use a viewport, hit numpad 1 and numpad 5 to have a viewport orthographic camera, which is necessary if you want to be able to rotate your canvas and stuff, because you cannot do that inside the actual camera unless you roll the camera itself, but it's hard to set up hotkeys that roll the camera itself. So, just do it this way. So there you go. That's the file setup. If setting all that up yourself sounds annoying, don't worry, because I'm just going to give it to you. I'm releasing several files this month. First up, we have a sample file that has the shader group set up, the connect group. It's everything we've just been looking at in this video, all of the layers, all the compositor setups and the outputs, just with my character file removed. So you can drop into your own character file, see how everything works. It's got the necessary script, all of that. To accompany it, we also have a version of the combine file. The first file renders out to the render folder, and then this reads in from the rendered layers folder. Same exact setup again. I've just removed character-specific stuff. So you've got the groups you need. I've removed like the background and some of the extra layers, as that's extra complexity you won't necessarily need, but you can set up whatever you want. All the node groups are here. And these two files will be for free on Gumroad for anyone who wants to test it out. And if you really like what you're seeing and want to help support me, this month's Patreon reward is the full combine file with the art included. I've included all the render layers at both 3K and a lower resolution for performance reasons. And this is available to anybody who signs up at least a tier 2 level on Patreon, and I'll leave it up through the end of September because this video is a bit late. And it will also be on the Gumroad link for a couple bucks. But wait, there's more. The full 3D model file of the Cybergirl is also available. Actually, an earlier version has been available for a few weeks. It's been released as part of the latest fundraising campaign for BlenderNPR.org's Beer render engine. If you're not familiar with it, Beer is a new render engine being developed by the community for Blender just for doing NPR rendering. The pack is an excellent value for what you get and funds a great project. It's got the Cybergirl and also 2 other scenes by other artists that are also really neat and worth checking out to see how they were made. And the version of the Cybergirl in there is being updated with all the changes and fixes I've made in the month since it initially went out. I've done a ton of material improvements, reorganized the shader, and more. There's 2 versions of the file being provided. One with all of these layers that we've been seeing in this video, and then also one without if you're not trying to recreate this workflow. And if you're signed up to my Patreon at any level, there's a post waiting there with a 50% discount code off of this pack. So you can help support me and them all at the same time. That's all for this video. Thanks for watching. Please like and subscribe and leave any questions you have, and I'll see you next video.